So in this video, we'll be solving discriminant questions from past papers. So let's start with our first question. Number 1 reads, a curve has equation y equals x squared plus 2cx plus 4 and a straight line has equation y equals 4x plus c, where c is a constant. Find the set of values of c for which the curve and the line intersect at two distinct points. So set of values means that our final answer will be in the form of an inequality. Then two distinct points means that the discriminant b squared minus 4ac is greater than 0. So let's take our two equations, the equation of the curve y equals x squared plus 2cx plus 4, and the equation of the line y equals 4x plus c. Let's equate them together. X squared plus 2cx plus 4 is equal to 4x plus c. Move all the terms to one side. Our goal is to get our equation to be in the form ax squared plus bx plus c. So let's move all the terms to one side. Becomes x squared plus 2cx. Let's move the 4x to the left hand side. It becomes negative 4x plus 4. Let's move the c to the left hand side. It becomes negative c is equals to 0. Now let's factor out the x here so we can clearly see our equation. And then this is 4 minus c is equals to 0. So from here we can now tell that a, the coefficient of x squared, is 1, and then the coefficient of x, b, is 2c minus 4. Then the coefficient of, or rather c, is equal to, in this case, it's 4 minus c. So now let's go back to our discriminant, which is b squared minus 4ac is greater than 0. Let's substitute our values into the discriminant. B is 2c minus 4. A is 1. And c is 4 minus c is greater than 0. Now let's expand this quadratic to be 4c squared minus 16c plus 16. Let's expand this, becomes negative 4, 4 minus c is greater than 0. Simplify this further by expanding that last bracket. That's negative 16 plus 4c is greater than 0. So 16 minus 16 will cancel out, and so we have 4c squared, and then negative 16c plus 4c will give us negative 12c is greater than 0. Now we have a quadratic inequality, so let's find the roots of the quadratic first. Let's factor out 4c. So we leave c minus 3 is greater than 0. So the roots of our quadratic will be c is equal to 0 or c is equal to 3. Now since this is a quadratic inequality, let's sketch our graph. Here we have our quadratic and we have our two roots. We have 0 and 3. Our quadratic sign, our inequality sign is greater than. So it means we want the region where the quadratic curve is above the x-axis. So in this case, that c is less than 0, which is this side, or when c is greater than 3. Remember how I say that set of values means they're asking us for an inequality. So as you can see, our final answer is in the form of an inequality. So it means we should be on the right track. Therefore, this is the final answer. C is less than 0 or C is greater than 3. Let's move on to question number 2. A line has equation y equals 3x plus k, and a curve has equation y equals x squared plus kx plus 6, where k is a constant. Find the set of values, again the set of values, of k for which the line and the curve have two distinct points of intersection. So this is pretty much the same as the first question. Two distinct points means the discriminant b squared minus 4ac is greater than 0. So again, we'll take our two equations, the equation of the line and the equation of the curve, which is y equals x squared plus kx plus 6. Equate the two equations together. 3x plus k is equal to x squared plus kx plus 6. Now let's put everything on one side. So let's move everything to the right hand side. Plus kx, if you move 3x, it will become negative 3x. Plus 6, if you move the k, it becomes negative k is equals to 0. Now let's factor out x here. Becomes k minus 3x plus 6 minus k. From here, we can deduce that our values are a is equal to 1 and b is equal to k minus 3, c is equal to 6 minus k. Right, we say that b squared minus 4ac is greater than 0. Now let's substitute in our values. B is k minus 3 squared minus 4a is 1 and c is 6 minus k greater than 0. Let's expand the quadratic, which is k squared minus 6k plus 9. This becomes minus 4 times 1 times 6, which is minus 24, minus 4 times 1 times minus k, which is plus 4k, greater than 0. Let's simplify the like terms. Minus 6k plus 4k gives us minus 2k. 9 minus 24 gives us minus 15, which is greater than 0. Now let's solve this quadratic. Again, this is a quadratic inequality. So I'm going to factorize this and we'll use 5 and 3. So this should be positive, rather negative 5, positive 3. 3 times negative 5 gives us negative 15. 3 minus 5 gives us negative 2. Yes. So our roots are k equals negative 3 and k is equal to 5. So remember that this is a quadratic inequality, so we sketch our graph, and at this point the root is negative 3, at that point it's 5. Since we have a greater than sign, again we want the region where the curve is above the x-axis. So it means we have two regions. K is less than negative 3 and k is greater than 5. This will be your final answer. Let's move on to question number 3. The line with the equation y equals kx minus k, where k is a positive constant, is a tangent to the curve with the equation y equals negative 1 over 2x. Find in either order the value of k and the coordinates of the point where the tangent meets the curve. So if the line is tangent to the curve, it means that the line and the curve only intersect once. And it means that we have one real root. So it looks something like this, which means b squared minus 4ac is equal to 0. So let's get our two equations. Y equals kx minus k. And we have the equation of the curve y equals negative 1 over 2x. Again, let's equate the two equations. Kx minus k is equals to negative 1 over 2x. Let's get rid of the denominator by multiplying through by 2x. So this becomes 2x multiplied by kx minus k, and this side becomes negative 1. Let's expand this, becomes 2kx squared minus 2kx is equal to negative 1. Put all the terms on one side, 2kx squared minus 2kx plus 1 is equal to 0. Now let's get our values for A, B, and C. A in this case is 2k. B is negative 2k. And C is 1. And we say B squared minus 4AC is equal to 0. So let's substitute. B is negative 2k squared minus 4a is 2k, and c is 1, and that becomes 4k squared minus 8k is equal to 0. We now have a quadratic. Let's vector out 4k, and this becomes k minus 2 is equal to 0. So the roots of the quadratic are k equals 0, or k is equal to 2. Now let's go back to the question and see what they want from us. Said find in either order the value of k and the coordinates of the point where the tangent meets the curve. As you can see, we have two values of k, right? We have k equals 0 and k is equal to 2. But they have told us in the question that where k is a positive constant, so it means we disregard k equals 0 and we take k equals 2. Therefore, k is equal to 2. Now that we know that k is equal to 2, let's find the coordinates of the point where the tangent meets the curve. So to do that, we will use the equation of this quadratic over here, because this equation is the equation of the curve together with the tangent. So let's take that equation. 2kx squared minus 2kx plus 1 is equal to 0. Let's substitute our value for k. Comes 2x squared minus 2 times 2x plus 1 is equals to 0. Simplify that. 4x squared minus 4x plus 1 is equal to 0. Okay, so let's solve this quadratic by factorization. It's 2x equals to 0, and that's a 1, that's a 1, then negative, negative. Okay, so in this case, 2x minus 1 is equals to 0. X should be equal to 1 over 2. Now that we have the value of x, we can evaluate our y value. The equation of the tangent is, rather, let's use the equation of the curve to get y. Negative 1 over 2x, so we substitute our y value, our x value here. 1 over 2, open bracket, 1 over 2, which should give us, these two cancel out, so it gives us negative 1. Therefore, the coordinates of the point of intersection are 1 over 2, negative 1. And k is 2. Let's move on to the next question. Question number 4. A curve has equation y equals kx squared plus 2x minus k, and a line has equation y equals kx minus 2, where k is a constant. Find the set of values of k for which the curve and the line do not intersect. So if the curve and the line do not intersect, b squared minus 4ac is less than 0. And again, they've asked for a set of values. This means that our answer should be in the form of an inequality. So let's write out our two equations. Y equals kx squared plus 2x minus k, and y equals kx minus 2. Equate the two equations together. Kx squared plus 2x minus k is equal to kx minus 2. Let's put everything on the left hand side. Plus 2x. If you move kx to the left, it becomes negative kx. If you move negative 2 to the left, it becomes positive 2 minus k equals to 0. Let's factor out x. This becomes 2 minus k. X plus 2 minus k is equals to 0. So this means that a is equal to k and b is equal to 2 minus k, and c is also equal to 2 minus k. And we know that b squared minus 4ac is less than 0. So let's substitute into the discriminant. B is 2 minus k squared minus 4, k is k, and c is 2 minus k is less than 0. Let's expand the quadratic. 2 squared is 4. 2 times 2 times negative k gives us negative 4k, k squared, and then this becomes negative 4 times k times 2, negative 8k, negative 4 times k times negative k, positive 4k squared is less than 0. So k squared plus 4k squared gives us 5k squared. Negative 4k, negative 8k gives us negative 12k. 4, it's only 4 plus 4 less than 0. Now let's solve our quadratic. We have a quadratic inequality. So let's evaluate the roots of that quadratic first. Okay, we can put a 2 here and a 2 there. And we want negative 12, so this should be negative. Okay, so here we have k is equal to 2 over 5, and k is equal to 2. Remember that we have been asked for a set of values, so our answer should be in the form of an inequality again. And so this point is 2 over 5, and this is 2. This time our quadratic sign is less than, so it means we want the region where the curve is below the x-axis, which is this region. So our answer would be k is between 2 over 5 and 2. That would be 4. Now let's move on to number 5. Okay, so it reads, find the set of values of m for which the line with equation y equals mx plus 1 and the curve with equation y equals 3x squared plus 2x plus 4 intersect at 2 distinct points. Again, this means b squared minus 4ac is greater than 0. So we get our two equations, y equals mx plus 1 and y equals 3x squared plus 2x plus 4. We equate the two equations. Mx plus 1 is equal to 3x squared plus 2x plus 4. Put all the terms on one side. We'll move everything to the right hand side. So mx will become negative mx plus 4. 1 will become negative 1 is equals to 0. So this becomes 3x squared. Let's factor out x here. 2 minus mx plus 3 is equals to 0. So our value for A is 3. Our value for B is 2 minus m. And our value for C is 3. B squared minus 4AC, as we said before, is greater than 0. So let's substitute. B is 2 minus m. That's squared. Minus 4a is 3. C is 3 greater than 0. So 2 squared is 4. 2 times 2, 4 times negative m, negative 4m. And then m squared as m squared. Negative 4 times 3 is negative 12. Negative 12 times 3 is negative 36, which is greater than 0. Okay, so let's rewrite this in descending powers of m. So this becomes m squared minus 4m plus 4 minus 36 is greater than 0. Simplify that. 4 minus 36 is negative 32, which is greater than 0. Let's solve the quadratic. So in this case, we have 8 and 4. So this is negative 8, positive 4, n is equal to negative 4, n is equal to 8. Again, this is a quadratic inequality, so let's sketch the curve. And then this point is negative 4. This point is m. Our sign is greater than, so we want the region where the curve is above the x-axis, which means that our final answers would be m is less than negative 4 and m is greater than 8.